Okay, so last video, and even though I know sometimes word problems can seem like, the moon a bit, you just really have to make sure that you are understanding what the vertex really means. So we are going to use the vertex form, which means we're going to complete the square because, again, we have talked a lot about the optimal value. So looking at, sorry, it's supposed to be a V. When like the max or min value and thinking about what y is. So we are going to use let statements so that if y is area or profit, then hopefully that will help us as well. Okay, so we are going to complete the square, and often we're going to have to do the lesson like 6.4 day 3, which is what happens when a is not equal to 1. So we have that always that extra step here. So we have to common factor the -1. And then leave the c value alone. And then we are going to take this b value. So half b squared is 36. And we're going to do, we want a trinomial again, so plus 36. And then when you minus the 36, you have to you have to multiply the -1. So you have to distribute to that and then leave the c value there. Then we factor the trinomial. Then simplify that. -36 times -1. And then simplify the like terms. Positive 36 subtract 17 is positive 19. So then the optimal value, so this is going to be, because it's down, the vertex is down. So again, our vertex is going to be, this would be left 6, so -6, and up 19. So we have a maximum value of y is 19 when x is -6, which is the vertex, of course, is the optimal value. So we're going to look at what happens when x means something and what happens when y means something when we do these word problems. Okay, so let's do this one over here. So remember, when you're trying to figure out what to common factor, you want to make a equal 1. So we're just dividing out the value here. So we have 6 So now we have our new b value here. So we're going to do -4 divided by 2 squared is -2 squared, which is 4. Make our trinomial. So the +4 is part of the trinomial. And then the -4 gets multiplied by 6. Inside, we're going to have -2, the number that was over here, minus 24 plus 65, which is positive 41. So now this is an up parabola. So that means this vertex is right and up. So 2 and 41. So it is a minimum value of 41 when x equals 2. Okay, so we are going to usually, often, to be practical, the word problems will deal with maximums, because it's like, what is the maximum area? What is the maximum height? What is the maximum profit, right? We're not usually looking for a minimum, sometimes, but maybe in these weird times, like what is the minimum amount of money something can make, but normally we are going to look for maximums. So as soon as you see the maximize, then that means really every single word problem, you're going to have to complete the square to find the maximum value or the optimal value if you prefer that, and make sure we are answering the question, okay, using the vertex. All right, so here we have Gio Salvatore is building a fence around the beach. Okay, so he has 1,600 meters of fencing to use. It'll only have 3 sides. So if it's the beach, you can assume like there's water. And then he's trying to make a fence around the beach. What dimensions of the fence, what should the dimensions be if he wants to maximize the area? Okay, so the perimeter is going to be 1,600. And it doesn't really matter, but this is usually length is longer, and then width is the 2 short sides. Okay, so make sure you have let statements, and we're going to say let A be area. Okay, so in this case, we need to write a quadratic equation. So when we're going to do 2 things here, and this is a little bit, this is the trickiest type, okay? So if we have perimeter and we have area. So area of a rectangle is length times width. And perimeter here, we have 2 widths plus a length. Usually you would say 2 widths plus 2 lengths, or length plus 2 widths. It doesn't matter what you write. But now we have too many variables, right? We have lengths, we have widths, we have P's, we have A's. We can't have that many. Okay, so since we want to maximize the area, we're going to use this here and this perimeter equation and rearrange it to go into the area equation. We're going to put the P equation into the A. Now, quadratic equation means that we need to have some kind of squared term. Okay, so whether it's x squared or L squared, W squared, whatever. So right now, these are both linear equations. So that's also a clue that we have a few steps here that we're going to do. So I'm going to sub in the P equals 1,600, 2 widths plus length, and then it doesn't matter what you pick. I'm going to pick length. Okay, so I'm going to say length equals, and then I'm going to bring the 2W to the other side, and it has to be subtract. Okay, now I can plug this into the area. Okay, so this is similar to what we did in the first unit. So now we have area equals length times width. Now I'm going to plug in 1,600 minus 2 width times W. And then I'm going to distribute. Now, if this bothers you, rewrite it. Okay, so distribute the W. And now we have a quadratic equation. Now we have something that has a squared term. Okay, so we've got a quadratic equation. So now we can start to complete the square. However, this is not written in standard form, right? So you can rearrange to ax squared plus bx plus c. Okay, there is no c value here, but we can do negative 2w squared plus 1600w. So now we've got, now it looks more like what we're used to, okay? So now we're going to complete square the square. So I'm just going to write number 3, step number 3 here, complete the square. So first we need to divide by 2. Oops, I do more. But divide by negative 2. Okay, and then I'm going to have, now this is b, so half of b squared. And if you don't know what 400 squared is, then put in your calculator. It's 160,000. So we're going to do the same thing. So add 160,000, subtract 160,000, which also has to be multiplied by negative 2. But there is no c value. Minus 400 is the number that was here. And now we have vertex form, right? So we have our vertex, and I'm running out of room, so I'm going to write up here. So what now you have to be careful. You make sure you answer the question. Okay, so finding the vertex form, we aren't done. All right, especially in this case here. So when you have, what we're trying to find is like what would the width be and what would the length be, right? We want to find the dimensions, I think. What should the dimensions be? So we need to find length and width. And it doesn't say what the maximum area would be, but the maximum area would be 320,000. But we don't need that. Well, all we need is the maximum width and the maximum area. So remember, when you're solving quadratic equations, you're looking for the value of w, or in this case, or usually we do x, but in this case it's w, that will make the equation equal to 0. So we're looking for which means you just need, is it meters? Yes. You just need the, whatever's inside the brackets of the vertex. And then in this question, make sure you solve for length. Okay, so therefore the dimension should be 400 by 800. Okay, so you're looking at this vertex form, and really what we're going to usually use is this value inside here. When will that be equal to 0? And then this number here is the maximum y value. So this is area, this is profit, whatever. And normally this is going to be negative because we want a maximum value for the vertex, which means open down. If you're looking for a minimum, then it will be positive and it would be open up, but it often will be a negative number for the a value. Okay, so another common one is looking at parabolic motion, or like what's the height. And we did this a little bit in the last unit as well. So again, we're looking for two things here. What height the t-shirts start at, and what is the maximum height. Okay, so the t-shirt started. That means that the start would be when is t equal to 0. So just put in 0. That doesn't work, sorry. So we have to, you always have to complete the square. And then we're going to find where the t is equal to 0, and we're going to find where the maximum height is. Actually, you can do A with just 0, but maybe it's easier to always use the vertex form. So we'll just do that, okay? So we'll complete the square to use vertex form. Okay, so let h be height, let t be time in seconds. Seconds? Does it say that? Usually it'll say in the question, we'll just do seconds. And we're going to complete the square. So this time we don't need to be given an equation, but it is the kind where the a value is not 1. So you're going to have to probably do that. So now the b value, -10 divided by 2 squared, -5 squared is 25. So add 25 minus 25, also adding -5. So then again, because it's a maximum, you can see we've got a negative a value, which is good. Okay, so the -5 is the factor, and then you get plus 125. So again, this equation has no c value, similar to that area equation as well. And that is going to be very common when we do standard form to vertex form by completing the square for word problems. Okay, so now we have vertex form. So we can do when did the t-shirt, what time did it start at? What height did the t-shirt start at? So when t equals 0. So we have -5 times -5 squared plus 125. So -5, that's an h, sorry, times 25 plus 125. So you get 0. So either way, I got 0 before as well. It doesn't really matter. But then in B, when you're doing the maximum height, you definitely need the vertex. Okay, so now we have, again, what time. If you're solving the equation, you're going to use this value in here, but the opposite sign. So t is going to be 5 seconds for the t-shirt to reach a maximum height of 125 meters. Okay, so that's why we made you do so many questions like the max value of y is 125 when x equals 5, right? We made you do so many of these questions because now our x and our y actually mean time and height. So our parabola is, like the vertex here, this maximum value, height is y. So that maximum height is 125 when x, or time, is 5. Okay? So during the summer months, Sarah makes and sells necklaces on the beach. Last summer, she sold necklaces for $10 each. Her sales averaged 20 per day. Considering a price increase, she took a small survey and found that for every dollar increase, she would lose 2 sales per day. If the material for each necklace cost Sarah $6, what should the selling price be to maximize profits? So the profit equation here is given. So again, this P is Y, and then you really have to think about what X is. So if we want to have, like, what are we looking for, right? So P is obvious. Let P be the maximized profits, and then we're trying to the X value is the number of price increases. So it tells us she started at $10, and so we're going to find how many dollar increases she should have. Okay, so again, there's that negative number that we need to factor out. And the B value, so half B squared minus 9 times -2 plus 80, x minus 3 squared plus 18 plus 80. Okay, so here now we have a vertex. So the maximized profit is $98. And so this occurs at 3 price increases, dollar increases. So if you really want to answer the question, what should the selling price be? Then if she started at $10, then she is going to, the selling price should be $13. 10 plus 3 price increases. Okay, so yes, you do kind of have to read the questions carefully, but the ones on the assignment will be pretty straightforward. Okay? All right. Last example. The cost C in dollars to hire landscapers to weed and seed a local park can be modeled by C equals 6x squared minus 60x plus 900, where x is the number of landscapers hired to do the work. How many landscapers should be hired to minimize the cost? Okay, so this time we are doing minimize, which means that we should have a positive A, not a negative, that our parabola is going to open up. Okay, but we're still going to do the same things. And actually, in this case, it already tells us cost is C, X is the number of landscapers. Okay, so you don't even have to worry about let statements. We're going to still divide by 6, but now it's a positive 6 because we are trying to minimize costs here, which makes sense. So now B, we've got -10 divided by 2 squared. Plus 25, minus 25 times 6 plus 900. Now we have a c value here at the end again. We're just going to leave it. X minus 5 is the squared. Negative 25 times 6 is negative 150. Okay, so now this question, it doesn't say what is the minimum cost, which would be $7.50, but if you wrote that, I wouldn't take marks off. Just make sure that you do answer the question. Therefore, the number of landscapers, that was terrible. So that's here, right? Because X is the number of landscapers. Then we want X equals 5. Okay, so even in these word problems, you should get whole-ish numbers, okay? And then again, next year will be a lot trickier. So here's some practice for the word problems. The review is posted as well. And then the last assignment will be on D2L starting Sunday in 2 parts. So make sure that you take a look at both. If you have any questions, please email. Thank you.